Dear students, in this video we are going to have an introduction to magnetism, Earth's magnetic field and magnetic elements, Earth's magnetic field and magnetic equator and magnetic poles, and also about the polar lights. In this lesson, magnetism and magnetic effects of electric current, we are going to study about the Earth's magnetic field and magnetic elements, basic properties of magnets, statement of Coulomb inverse square law of magnetism, magnetic dipole, magnetic field due to a dipole along axial line and equatorial line, torque acting on a bar magnet in a uniform magnetic field, potential energy of a bar magnet placed in a uniform magnetic field, magnetic properties such as permeability, susceptibility, etc., classification of magnetic materials like dia, para, and ferromagnetic materials, concept of hysteresis, magnetic effects of electric current along state, conductor, and circular coil, right and thumb rule and Maxwell's right and corkscrew rule, Faraday-Sauer's law and its applications, tangent law and tangent galvanometer, current loop as a magnetic dipole moment of revolving electron, Ampere's circuit law and its applications, solenoid and toroid, Lorentz force, charged particle moving in an electromagnetic field, cyclotron, force on a current carrying conductor in a magnetic field, force between two long parallel current carrying conductor, torque on a current loop in a magnetic field, and finally about moving coil galvanometer. Let us have an introduction to magnetism. Here we are all excited to know that a magnet will get levitated when it is placed near another magnet, which is a very strong one, and this is called as magnetic levitation. So these magnets, they will attract everyone, and the world enjoys their benefits to lead a modern luxurious life. The study of magnets fascinated scientists around our globe for many centuries, and even now, door for research on magnets is still open. The birds and animals use their magnetic sense in their eyes. For navigation, they use this magnetic field. Magnetic sensing in eyes for zebra finch bird due to protein cryptochromes, that is PRY4, present in retina. The bird uses its magnetic field for navigation. Its magnetism exists everywhere, from tiny particles like electrons to the entire universe. Historically, the word magnetism was derived from iron ore magnetite, Fe3O4. In olden days, magnets were used as a magnetic compass for navigation, magnetic therapy for treatment, and also used in magic shows. In modern days, many things we use in our daily life contain magnets. Motors, cycle dynamo, loudspeakers, magnetic tapes used in audio and video recording, mobile phones, headphones, CD, pen drive, hard disk of laptop, refrigerator, door, generator, are few examples. Earlier, both electricity and magnetism were thought to be two independent branches of physics, but in 1920, H.C. Oersted observed the deflection of magnetic compass needle kept near a current-carrying wire. This unified the two different branches, electricity and magnetism, as a single subject called electromagnetism in physics. In this unit, basics of magnets and their properties are given. Later, how a current-carrying conductor behaves like a magnet is also presented. Here, the diagrams of objects which uses magnets are given. The first is the speakers, next headphones, your MRI scan, and hard disk of a laptop. Now we are going to study about this magnetic field and what are the magnetic elements. Here, from the activities performed in lower classes, you would have noticed that the needle in a magnetic compass or freely suspended magnet comes to rest in a position which is approximately along the geographical north-south direction of the Earth. So this is the Earth's magnetic field. And this is the magnetic south pole and this is the magnetic north pole. Whereas the geographic north pole lies here and geographic south pole lies here. Then the north pole of the magnetic compass needle is attracted towards the magnetic south pole of the Earth, which is near the geographic north pole. Similarly, the south pole of magnetic compass needle is attracted towards the magnetic north pole of the Earth, which is near the geographic south pole. What is geomagnetism? That's the branch of physics which deals with the Earth's magnetic field. That is called as geomagnetism or terrestrial magnetism. There are three quantities required to specify the magnetic field of the Earth on its surface. They are called as the elements of the Earth's magnetic field. They are magnetic declination denoted by letter D, magnetic dip or inclination denoted by letter I, the horizontal component of the Earth's magnetic field denoted by BH. So this is the bar magnet, and which is assumed to be kept inside the Earth magnetic south pole, and this one is Earth magnetic north pole. Magnetic field lines will be like this, and here this geographic meridian is given by this D, and these are the angle of declination, that is the angle between the geographic meridian and the magnetic meridian. Day and night occur because of the spinning of the Earth about an axis called geographic axis. The vertical plane which passes through the geographic axis is called the geographic meridian, and the great circle which is perpendicular to Earth's geographic axis is called the geographic equator. The straight line which connects magnetic poles of Earth is known as the magnetic axis. And the vertical plane which passes through magnetic axis is called magnetic meridian, and a great circle which is perpendicular to Earth's magnetic axis is called the magnetic equator. When a magnetic needle is freely suspended, the alignment of the magnet does not exactly lie along the geographic meridian. The angle between magnetic meridian at a point and geographic meridian is called the declination or magnetic declination, D. And at higher latitudes, the declination is greater, whereas near the equator, declination is smaller. In India, declination angle is very small, and for the city Chennai, magnetic declination angle is about -1 degree and 16 minutes, which is negative. The angle separated by the Earth's total magnetic field B with the horizontal direction in the magnetic meridian is called dip or magnetic inclination I at that point. And for Chennai, the inclination angle is about 14 degrees and 28 minutes. The component of Earth's magnetic field along the horizontal direction in the magnetic meridian is called horizontal component of Earth's magnetic field, denoted by letter BH. Let E be the Earth's magnetic field at any point on the surface of the Earth, and this E can be resolved into two perpendicular components. The horizontal component BH, that is given by B cos I, and the vertical component BV equal to B sin I. So dividing these two equations, we get this equation tan I equal to BV by BH. And at the magnetic equator, the Earth's magnetic field is parallel to the surface of the Earth, which implies that the needle of the magnetic compass rests horizontally at an angle of dip, that is I equal to 0 degree. So BH is equal to BE and BV equal to 0. This implies that the horizontal component is maximum and vertical component is 0 at the equator. And at magnetic poles, the Earth's magnetic field is perpendicular to the surface of the Earth, that is vertical, which implies that the needle of magnetic compass rests vertically at an angle of dip I equal to 90 degrees. So BH is equal to 0 and BV will be equal to BE. This implies that the vertical component is maximum at the poles and the horizontal component is 0 at the poles. Here the polar lights are explained, how they are formed and what's the reason behind that. Then we will study about the basic properties of magnets.